Semiconductors are divided into two types: intrinsic semiconductors and extrinsic semiconductors. Intrinsic semiconductors and extrinsic semiconductors, or else we can say this one as pure semiconductors. This one, impure semiconductors. We can consider this one as pure semiconductors or intrinsic semiconductors. These are as extrinsic or impure semiconductors. So let's see what are intrinsic and extrinsic. Let's take silica. We know this one, 14 group, it comes in 14 groups, and valence is 4 for this silica. So if at all such sort of this is in general at normal temperature, this forms 4 bonds with other silicon. If at all temperature increases here, then what happens? Electrons start shifting from one position to another position, from lower state to higher state. So here I am increasing the temperature. So the electrons are going to shift from here to here, and then here to here, and then here to here, from lower energy to higher energy as I am increasing the temperature. This one is extrinsic or intrinsic semiconductors. Pure one. Only the major point is this one is not at all having any impurity. This purely depends on temperature. If we increase the temperature, electron shifts from one position to another position, from lower state to higher state. This is about pure one. Then what about the impure one? Extrinsic semiconductors. These are also two types. One is P type and the next one is N type semiconductors. Positive type semiconductors means positive excess. If at all, this is N type. Positive excess means, let's take same example for this one also. If at all we'll take the pure one, pure silica structure like this, then this is intrinsic semiconductor. If at all, this is 14 group. If at all any 13 group element, 13 group means boron, aluminium, gallium, indium, thallium. Silicon comes in 14 group. 14 group carbon, silica, germanium, tin, lead. This all comes in 14 group. And this is 13 group. If at all in this silica, pure silicon compound, any 13 group element is added, means nothing but if we remove one silica and if we add one 13 group element, then that is known as P type semiconductor. So let's see. But the difference here is silica is showing valency 4, but whereas 13 group shows valency 3. Then what happens? Okay, in the previous case, silicon is bounded in a crystal like this. It is forming 4 bonds as it is having valency 4. et al., we replace one Si with 13 group element. 13 group elements, say indium. This is nothing but replacement of one element with another, that is doping, addition of impurity. We are changing the pure form of this crystal structure by adding this 13 group element as impurity. Then that is known as doping. Okay, fine. We added one impurity here. But then what about the structure? This will not be the same because as this is 13 group element, it shows only +3. Valence electrons is +3. Valency of this 13 group elements is +3. So what happens here? Okay, this forms a bond with only 3 elements. Then what about the fourth one? What about the fourth position? It does not form a bond here. Instead of bond, a hole is erased. A hole created automatically. Space is created automatically as it has only 3 electrons to form a bond with another element. So, in the earlier case, if we supply temperature, if we increase the temperature, then only the movement of electrons happens. Then only conductivity is going to change. But what about here? We don't need to apply or supply any excess temperature here. Even in normal temperature also, the electrons moves very freely. The electrons moves very automatically as a hole. Automatically a hole is formed here. So this hole is positive one because we are using 13 type group elements. We are doping with, as it is 14 group, we are using 13 type element as an impurity. So this sort of a semiconductor is P type. Same opposite. If we use impurity of 15 group instead of 13 group to the 14th group element, then that doping is called as, then that is also doping. Then third type of semiconductor is known as N-type semiconductor. Then that sort of a semiconductor is N-type semiconductor. So, but the difference is here, 13 group element shows valency 3, but the 14 group shows 4. Then what about this 15 group? It shows 5. But the valency here is 5. So let's see how it happens. First of all, we'll see normal silicon 14 group element. In that 14th group element, we are doping some element with the 15th group. What are 15th group elements? Nitrogen, phosphorus, arsenic, antimony, bismuth. As we know, we can't do doping with these two as 2 are gases. So with these 3 we can do doping. So let's take arsenic here. So we'll remove one silica with arsenic. So fine. This arsenic also forms 4 bonds with the neighboring elements as it is having +5 valency. So 4 is utilized here. Then what about the 5th valence? One free, as it is stays as free electron. So in this case also same availability of free electron. So Ease of free electrons is more in this case also. So obviously conductivity is also more in this case due to the availability of free electron. In the p type also conductivity is more. When we compare between intrinsic and extrinsic, p type is also having more conductivity, and as well as n type is also having more conductivity, though because of availability of free electrons. These two are nothing but, these two comes under nothing but impure defects and electronic defects.